So continuing solutions on the final exam. Here is problem number 4. This was one version of it. There were 3 different ones. Unfortunately, one of them was flawed. I'll talk about it in just a minute. We want to find area under this function above the x-axis. And I actually asked for an integral. You didn't have to evaluate it. Just show me the integral and be good enough. So the first step, I think, is to find the intercepts. Hopefully everyone knows this function is a parabola, and the way the problem is described, the vertex is going to be above the x-axis and it opens down due to the negative sign right there. So we find the intercepts. There's one at 0, there's one out here at 9/5. And so the function looks something like that. And we're looking for the area right there. The integral that does the job is from 0 to 9/5 of the function, 18x minus 10x squared. And like I said, I didn't ask you to evaluate it, so we're good right there. That locks in 10 points. Now, generally I made small editing changes between the 3 exams, mostly so the answers would be different, and I did that on all the exams, so you're used to it. The problem is for exam 3, I inadvertently deleted that square, and it totally changes the problem. It makes it impossible, in fact. I think the numbers they had were 14 and 4, so their function looked like 14x minus 4x. Well, that's just the function 10x. A line with slope 10, and if we're looking for area underneath it, well, that's infinite. I mean, it's not a very interesting problem. So I apologize. I will grade the problem very generously because it was my mistake. Fortunately, it's an easy problem, so I don't think it'll be that big of an advantage to have yours graded generously. But, it happens. I apologize. I won't let it happen again, at least in Calc 1. How's that? All right, problem number 5. It's kind of a fun problem. I'm going to find the antiderivative. I'll go back to black. Let me write the symbol here of x cubed times the square root of 4 plus x squared. I believe the only difference on the 3 exams was maybe the number 4, which is totally a trivial change. So this was like a problem on the last exam where you make a substitution and it doesn't quite eliminate all the x's. And so we need to go back to the substitution and get a little bit more information. So we're going to go like this, the inside of a composition, as almost always we do. Immediately find the differential relationship. And now let's write the integral in terms of u. And so notice I have 3 powers of x. I can only account for one of them with the differential, which is going to leave 2 of them. So let's just leave them here. And then if I divide by 2 both sides, then I can replace the other x, the third one of these 3, with 1/2 du. There's the 1/2. And we'll write the du over here. And then, of course, we have the square root of u. So just from the substitution and the differential, we get this, which is not good enough because it has x's in it. But fortunately, it's easy to solve for x squared, the piece that's remaining, using our substitution. So just subtract the 4 across. And so we get 1/2 the integral of u minus 4 square root of u du. And the antiderivative of that, let's write one more step. Let's distribute the square root. So I get u to the 3/2 minus 4 u to the 1/2. And now we have it nice and easy. 1/2 times 2/5 u, which is 4 plus x squared, to the 5/2. So raise the power divide by or multiply by the reciprocal since it's a fraction, and minus 4, and then we're going to raise u to the 3/2 and then multiply by 2/3. Okay, so there you go. There is no product rule, so you have to use the substitution to eliminate the square. There is just no other way to do the problem. All right, that's number 5. Number 6. So 6 is a related rates problem. I think it's pretty routine. We want to find the rate of change of the diameter of a circle. And we know the rate of change of the area, so I'm going to be a little bit efficient here. Just going to write the important stuff down. The area is changing at the rate, and again, it probably varied from test to test. The one I'm looking at, it's 3, increasing. And we want to find the rate of change of the diameter, little change there, not the radius, the diameter. And we want to evaluate it when the area is 25. Okay, so there are a couple ways we can go about this. I'll show them to you. The area is pi r squared. So that writes the area as a function of the radius. So let me draw a bar here. I'll do it, the two methods on either side. So the other way would be to replace r with what it's equal to in terms of the diameter, which is d over 2, and square that, and then we would get pi over 4, it looks like, d squared. So you can use this, calculate dr dt, and then double your answer. The diameter will be increasing at twice the rate of the radius, or you can use this guy over here. It doesn't matter. Either one ought to get us the right answer. So maybe I can quickly do both of them. So dA dt, again, I haven't looked at any exams, so I don't know what you did. 2 pi r dr dt, of course r and a are functions of time. And so dr dt is 1 over 2 pi r times dA dt, but remember, that's all jammed up there. It's 3. There it is. So we'll multiply by 3. And then we need to know the value of r when the area is 25. So 25 equals pi r squared, and therefore r is the square root of 25, which is 5, over the square root of pi. So plug that in. You didn't have to simplify it. It doesn't matter. That's the rate of change of the radius, and then double your answer. So let's write it out here in ugly form. If I had a little more time, I would simplify it just because it's prettier. But here's our answer. d dt equals twice. See if I can get rid of some stuff here. Nope, got rid of the wrong thing. Okay. Well, shoot. So take what I got there and plug it in. Okay. So I'll just go ahead and solve it the other way. If I remember right, we were able to write the area as pi over 4 times d squared. And then dA dt is pi over 2. Bring the 2 down. Turn the 4 into a 2. d dt. This looks like a better way to solve it. And so I missed a d there. 2d d dt. And so dd dt is 2 over pi d times dA dt, which is 3 if I remember right. And then we just solve for the diameter up here when we know that A is 25. Okay, simple algebra. I'll let you do the work. So hopefully those answers will be the same since I accidentally eliminated part of the first one. Won't get the verification, but either way is fine. I'll take a look at your work and see how it went.